Hi, this is Mrs. Downey, and this is the chapter review for Chapter 9, and over sequences and series. This is our study guide for the test. Our first question starts off with generate the first 5 terms in the sequence using the explicit formula. Well, the explicit formula they've given us. So they've given us C of n is equal to negative 2n minus 2. So to get the first 5 series for these, you just have to set n equal to 1, 2, 3, 4, and 5. Plug that into the formula and get the answer for each term. At the end, you'll have all 5 terms for your answer. So let's start with number 1. So for the first term, we're going to plug in 1. So C of 1 is equal to negative 2n, which is 1 minus 2. Well, negative 2 times 1 is negative 2. Negative 2 minus 2 is negative 4. So there's our first term, negative 4. The next term for 2, we'll say C of 2 is equal to negative 2 times 2 minus 2. Well, negative 2 times 2 is negative 4, and negative 4 minus 2 is negative 6. For our next term, we have the third term, C of 3. It's equal to negative 2 times 3 minus 2. So negative 2 times 3 is negative 6, and negative 6 minus 2 is negative 8. C of 4 is equal to negative 2 times 4 minus 2, which is negative 8 minus 2, which is negative 10. And last term, C of 5 is equal to negative 2 times 5 minus 2. Negative 2 times 5 is negative 10, and negative 10 minus 2 is negative 12. And these right here, negative 4, negative 6, negative 8, negative 10, and negative 12 is the first 5 terms of this sequence using that explicit formula. Our next problem, number 2, says what is the 15th term in the sequence using the given formula? Well, they give us C of n equals 13n plus 7. So that means if we want the 15th term, we're going to say that n is equal to 15 and substitute that in our explicit formula. So C of 15 is equal to 13 times n, which is now 15, plus 7. Well, 13 times 15 is 195, and then 195 plus 7 is equal to 202. So C of 15, which represents our 15th term in the sequence, is 202. Number 3 states, write a recursive formula for this sequence, 7, 9, 11, 13, and 15. Then find the next term. So the first thing we want to do is write a recursive formula. In a recursive formula, it says state the problem in terms of n as compared to the previous term, which would be our n minus 1. So you always want to start with the second term or higher so you can compare it to the one before it. So let's just work with the second term and then compare it to the first term. How can we state? So to say that 9 is equal to, well, what's it equal to with the second term? The second term as opposed to the first term? Well, the second term is 9, the first term is 7. So how can we make this a true statement? Well, 9 equals what? 7 plus 2. And if we say that 9 is our n, and 7 is our n minus 1 term, well, then we can rewrite this like a sub n is equal to a sub n minus 1 plus 2. Now check and see if that is true for another statement. So let's look at 15. 15 is equal to 13 plus 2, and that is a true statement. So this is our recursive formula, and with the recursive formula we always have to state our first term also with a sub 1 equal 7. Okay, and then they wanted to know also what is our next term in the sequence. Well, 15, what are we doing each time? Well, we're just adding 2 each time. So it would be 15 plus 2, which is 17. That's our next term. And this is your answer. A sub n equals a sub n minus 1 plus 2 with a sub 1 equals 7, and the next term is equal to 17. The next problem asks us, is the sequence arithmetic? If so, identify the common difference. Well, the first thing, they talk about the common difference. That means to subtract. So we're going to start with the second term, 15, and subtract 10 from that. So 15 minus 10 is equal to 5. And let's follow suit for the rest of these. 20 minus 15 is also 5. And 25 minus 20 is also 5. So in all three differences, they have the same number, the same difference of 5. We call that the common difference. Because they have a common difference, this means yes, it is an arithmetic sequence, and the common difference, D, is equal to 5. Our next problem says find the 50th term of the sequence 5, -2, -9, and -16. Well, we first want to see if it is arithmetic or geometric. So let's just try arithmetic first. Let's try taking the difference. -2 minus 5, which equals -7. And -9 minus -2 equals -7. And -16 minus -9 turns to a positive is equal to -7. So they have a common difference of -7. So this is an arithmetic sequence with a difference of -7. So we've got a common difference of -7. And let me erase these. And now we know our first term, a sub 1, is 5. Okay, so we know that n is 50. So now we can apply our explicit formula. A sub n equals a sub 1 plus n minus 1 times d, and we can get our nth, our number of terms, our n value. So let's plug everything in. So a sub 50 is equal to a sub 1, which is 5, plus 50 minus 1 times -7. So 50 minus 1 is 49, and 49 times -7 is -343. Well, we have to add 5 to that, and we get -338. And that is the 50th term of our sequence. -338. Number 6, ask us to find the missing term of the arithmetic sequence. And they give us 30, a missing term, and 24. So we just have 3 terms that we're looking at. The first one's identified, the third one's identified, but the second one's missing. When you have this with an arithmetic sequence, all we have to do is average them. So take 30 plus 24 divided by 2. which gives us 54 divided by 2, which is equal to 27. So that's our missing term, 27. On the next problem, number 7, it says, is the sequence geometric? If so, identify the common ratio. Well, for geometric sequences, we know that you must multiply from one term to the next. So you have to multiply something to one term to get to the next term. Let's see, how could we figure out what that is? We'll just use the ratios. So start with your second term, 8 divided by 2. And then take 32 divided by 8. And then take 128 divided by 32. When you do this, each time they simplify to 4. So they have a common ratio. The common ratio will represent with r is equal to 4. Because they have a common ratio, we say these terms are yes. They are geometric sequences with a common ratio of 4. Number 8 states, what is the fifth term of the geometric sequence? And they give us 3, 6, 12, and so on. And our first step is we want to look at the difference or the ratio. So we're going to take 6 over 3 and 12 over 6. In 6 over 3 we have 2, 12 over 6 we have 2, so we have a common ratio of 2. We know we have our first a sub 1 value is equal to 3, but we don't know how many terms are in the sequence. But all we're looking for is the fifth term. So we're going to let n equal 5. So now let's get started. We're going to start with, going to reset. We're going to start with our explicit formula, which states a sub n equals a sub 1 times r sub n minus 1. Okay, so we're going to take these values over here and plug them into this formula and solve. So a sub 5 is equal to a sub 1, which is 3, times our common ratio of 2 to the n, which is 5 minus 1. So this becomes a to the 5 equals 3 times 2 to the 5 minus 1 power, which is 4. Well, 2 to the 4th power is 2 times 2 times 2 times 2, which is 4, 6, 12. Excuse me. I just totally did that wrong. Let's do that again. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I knew that was wrong. Alright, so we've got 16 here. 2 to the 4th power is 16. So we have 3 times 16. So the fifth term is 3 times 16. And 3 times 16 is 48. So our fifth element is equal to 48. Number 9 asks us, what is a possible value for the missing term of the geometric sequence? Well, we know to find when we've got 3 terms, the middle one's missing in a geometric. As in this case, what are we going to do? We're going to multiply the first and third term together, then take the square root of them. So let's do that. What is the square root of 34 times 1,224? Well, that's going to be equal to, this is a sub 2 there, a sub 2. Alright, so it's going to be equal to 41,000 646. And when you take the square root of that, you get that that second term is equal to 204. And that's your answer. So what goes in here? 204. Number 10, they ask us what is the sum of the finite arithmetic series. So the first thing we want to do, because it's an arithmetic series, we can go ahead and get our difference. 36 minus 30 is 6, and that should be good for all of them, but I want to double check a couple more. 42 minus 36 is also 6, and 48 minus 42 is 6, and so on. So we are certain that our difference is equal to 6, our common difference. So now our next thing, we want to go ahead and check. We know that a sub 1 is equal to 30, and we've got our a sub n, which is equal to 90. So what I want to do first is find the number of terms, and we need to know that to get the sum. We have to have our n value, which we don't have right now. But we do have a lot of information, and let's go ahead and plug in what we have into the formulas that are available to us. So we've got our explicit formula of a sub n equals a sub 1 plus n minus 1 times d. So let's just plug in everything we have here and solve for n. So we know our a sub n, our last term, is equal to 90, and our first term is equal to 30, so we've got those two, plus n minus 1 times our difference, and we know the difference is 6. So now distribute that 6 across, so 6n minus 6 plus 30 equals 90. And 30 minus 6 is 24 plus 6n equal 90. And subtract 24 from each side. And we're going to get 66 equal 6n. So n is equal to 11. So now we have what we need to get the sum of our finite arithmetic series. Okay, so now that we have our n value, we're going to plug this in to the next formula. Our summation formula. S of n equals n over 2 times a sub 1 plus a sub n. So now that we do this, we're going to say S of, let's rewrite that. S of 11 equals 11 divided by 2 times our first term plus our last term, 90. And 30 plus 90 is 120. So basically we have 11 halves times 120 over 1. We can go ahead and cancel out the 2 and turn 120 into 60. So now we just have S of 11 equals 11 times 60, or 11 times 60 is just 660. So the summation of our 11 terms is 660. Number 11 says use summation notation to write the series 59, 64 plus 69 plus forever and ever for 13 terms. So already we know that n equals 13. So we have that. And we know that our first term is equal to 59, and we do not know our last term. So this is what we're given. Let's see if it's an arithmetic series. Does it have the same difference? So 64 minus 59 is 5. 69 minus 64 is also 5. So yes, this is an arithmetic series with a difference of 5. If that hadn't been the same, I would have checked for geometric series by taking the ratio 64 over 59, 69 over 64, and comparing. So our next step is to write the explicit formula a sub n equals a sub 1 plus n minus 1 times d. And we're just going to work the right-hand side because we are trying to use the summation notation, the sigma, with the n equals 1. And they already told us for 13 terms, so 13 goes there. But now what's our formula? It goes to the right of it. Well, that's what we're going to figure out next. So let's just work the right-hand side of this formula. And so we have equal to a sub 1, which is 59, plus n minus 1 times our difference. And our difference, I said, was 5. So now the 5 distributed is 5n minus 5 plus 59. Now 59 minus 5, combining like terms, is 54 plus 5n. Now we want to write this in summation form. We want to put it in standard form. So put your variable term first. So 5n plus 54. Okay, so now we've got everything we need. So we can write this as, let's get rid of this. We could say 5n plus 54. You could write it like this, or you could write it like this. Okay, either way will be correct. Our next problem, number 12, says evaluate the series 1 plus 4 plus 16 plus 64 plus 256 plus 1024. Well, our first step would be to decide, is it geometric or arithmetic? Well, let's subtract our terms. 4 minus 1 is 3, and 16 minus 4 is 12. Well, right off the bat, we know it's not arithmetic. So let's look at geometric. Let's take ratios. 4 over 1 is 4. 16 over 4 is also 4. And if you were to evaluate the rest of these, so it would be 64 over 16 is 4. The rest of them yield 4. They all have a common ratio of 4. So we know r equals 4, and we know that our number of terms is equal to 1, 2, 3, 4, 5, 6. And if they had an ellipsis in there, and we didn't have a finite set of terms, we would have to solve using the explicit formula and find our n terms. But since we have them, we can count it. So now we know we're going to need this. We need our first term, so our a sub 1 is equal to 1. And our last term, a sub n, is equal to 1024. Now let's use our summation formula. So s of 6 terms is equal to, or we could say s of n, let's rewrite this. S of n is equal to a sub 1 times 1 minus r to the n power all over 1 minus r. So let's plug these in. So the summation of our 6 characters here, our 6 terms here, are the first term times 1 minus our rate, which is r, which is our 4, to the 6th power, all over 1 minus r, which is 4. So now let's continue to solve. So the summation of our 6, 1 minus 4 is negative 3, and 4 to the 6th power is 4096. And so we have 1 times 1 minus 4096, which is negative 4095. And 1 times that is just that, negative 4095 over negative 3. And when you solve that, you get 1,365. And that's your answer. The summation of the 6 terms is 1,365. Number 13 says, does the infinite geometric series diverge or converge? And explain. Well, because it's geometric, it means we're multiplying it by something each time. And if we look at our first term of 1/3, and then we look at our second term, which is 1/15, well, you could take the ratio of 1/15 divided by 1/3, and we know that a fraction divided by a fraction, you just flip the second term, 3/1, and multiply. So you get 1 times 3, which is 3, over 15 times 1, which is 15, which comes out to 1/5. So you would do that again with all your terms, and you would find that you've got a common ratio of 1/5. Some of you might see right away, well, we're just multiplying each denominator by 5 each time. That's right too, but because it's a denominator, it would be 1/5. So we've got a common ratio of 1/5. So because that falls between 0 and 1, then we know that this converges and it will have a sum. Okay? If it's greater than 1, it would have been a diverge. So let's look at the next example. Now we're also looking for the same patterns. Let's see if we have 20 over 4, that's 5, 100 over 20, that's 5, and 500 over 100, it's 5. So we have a common ratio of 5. That is greater than 1. So our ratio is greater than 1. That means we have it's diverging. And there's no sum to attain. And that concludes our review. That's everything on the test. Study hard, and this should be quite an easy test for you to pass and do well in. Go over this at least 3 times with your study guide, which is also on Google Classroom, and do well. Study hard and do well. Thank you for watching.